Hello everyone. Welcome back to the Unity FPS controller series. In this video, we are going to add some very important FPS features. We'll create a damage system, add a new script called damageable. Spawn blood particles when we hit an enemy. Spawn default hit particles when we hit walls or other objects. Add weapon sway. And finally, we'll create a weapon recoil system. First, let's create our damage system. For this, we need to give damage from our weapon. Let's add a new float variable, so every bullet that hits, give damage. Let's add a new private float weapon damage and set its value to 25. The next thing we want to do is actually give damage when our weapon ray hits something. Right now, our gun is shooting the ray correctly, but nothing happened, and we need to give damage. So first, before writing the shooting logic, we actually need to create that damageable script. First, let's add a capsule in our game that will act as a damageable object. Create empty object and rename this as enemies and reset its position. Inside this, create a capsule and rename this as enemy1. This will act as damageable object. Next, let's adjust the position for our enemy and place it in front of our player so we can easily shoot it. Now, really quickly, I'm just going to create a simple material for the enemy capsule and assign it for better visibility during testing. Right-click and create a new C# script and rename it to damageable. This script will be attached to anything that can take damage, for example, our enemy. Let's attach it to our enemy. Open damageable script. This script is going to be responsible for handling health and taking damage. Let's add a new private float, current health. Let's duplicate this current health float for our max health and set its value to 300. Max health will be the total health our enemy can have, and current health will store the enemy's current remaining health during gameplay. Now inside start, when the game starts, we initialize current health with the maximum health value. So basically, the enemy starts with full health. Let's remove update method. Next, we'll add a new public take damage method. Public void take damage, and add a float parameter called damage amount. First thing in this method is we'll subtract the incoming damage from the current health. Let's say current health minus equals damage amount. Next, we'll check if the health becomes 0 or less than 0. Then we'll destroy the enemy game object. Now this is a public function because we want other scripts like our weapon controller script to access it and apply damage. Now inside our raycast check, first we're going to try getting the damageable script from the collider we hit. Damageable equals ray hit dot collider dot get component damageable. What this line does is it checks the object hit by the ray and tries to find a damageable component attached to it. Next, we'll check if the object actually has the damageable script attached. Let's say if damageable is not equals null. Now we'll call the take damage function damageable dot take damage. We'll pass our weapon damage value into it. Now, before moving further, let's create a simple crosshair for better aiming. Right-click, UI, canvas, and rename it to weapon control canvas. Let's change UI, scale mode, and set the resolution and match values. This helps keep the UI properly scaled across different screen resolutions. Next, let's create an image inside our weapon control canvas and rename it to crosshair. Next, we'll set both the width and height to 25. Let's add Unity knob sprite for source image and change its color to red. Let's test the damage system. Every shot decreases the enemy's health, and once the health becomes less than or equal to 0, the enemy gets destroyed automatically. Right now, when we shoot the enemy, it only takes damage, but there should be physical reaction from the bullet hit. For this, we'll add an impact force to make the shooting feel more satisfying and realistic, and we'll apply force to the object when the bullet hits it. Select enemy capsule and add rigid body component. And from constraints, freeze X and Z rotation. Open up our weapon controller script. First of all, let's create a new private float and call this as bullet force and set its value to 10. Now let's get rigid body component from the collider we hit that we did for damageable. If the object has a rigid body attached, then we can apply force to it. If the rigid body exists, then rb.addForce, and for force direction, minus ray hit.normal, and multiply with bullet force. Let's test our impact force. But before we starting shooting, let's quickly increase the bullet force from 10 to, let's say, 100. Now, as you can see, when the bullet hits the capsule, it gets pushed backward. That means our rigid body impact force is working correctly. When our bullet hits the enemy takes damage correctly, but there's no visual hit feedback yet. So let's add a simple blood hit effect. Open up our weapon controller script. Let's create a new public game object blood hit effect. Now, inside our shooting method, after applying damage, I'm going to instantiate the blood effect. Let's say game object blood equals instantiate. An object to instantiate is blood hit effect, and position is ray hit dot point. And for rotation, quaternion dot look, rotation ray hit dot normal, and then we'll destroy that blood game object after 2 seconds. Right now, this approach is completely fine for learning and prototyping, but later in a future episode when we cover object pooling, we'll optimize the system properly and use object pooling instead of constantly incendiating and destroying effects like blood particles and other VFX. I already have the blood splash particle effect, and I'll assign its reference to blood hit effect of weapon controller. Hit play button and test our blood effect. You can see the blood effect is spawning correctly. And the best part is that it's coming exactly from the point where the ray hits the enemy. Now, if I rotate the player left and right, you can see our gun is still completely static. It is not reacting to the camera movement. And that does not feel very good for an FPS game. So now let's add a simple weapon sway system. Weapon sway means the gun will slightly move opposite to our mouse movement, which makes a weapon feel more alive and natural. Let's create a new script and rename this as weapon sway. Open up weapon sway script, and here first thing we need to do is to remove mono behavior because we don't want this class to drive anything. Let's add serializable because we want to use this inside our weapon controller script. We don't need start and update. Next, we want a variable that controls how far the weapon can move. Let's add private float sway clamp and set its value to around 0.05. Next, we need a variable that controls how smoothly the weapon follows the sway position. Let's have private float smooth time and set its value to 5. Next, we need original local position. So the weapon always sways around its original position. Let's add public vector 3 origin pose. It's public because we'll set it in weapon controller script and hiding in inspector because we don't need to edit it manually. Now let's create the main method that will handle weapon sway system. Let's add public void gun sway and pass transform parameter for weapon transform to apply sway movement to it. Let's add a couple of floats for our mouse input. Let's say float mouse x equals input dot get access mouse x. Duplicate this for our mouse y input and replace x with y. Next, we need to store both values inside of vector2. Let's add vector2 mouse input equals new vector2 for x, mouse x, and for y. After that, we need to clamp the mouse input because we don't want the gun to move too far when we move the mouse quickly. Let's clamp x input first, mouse input.x equals math f.clamp. And we want to clamp mouse input.x minus sway clamp to positive sway clamp. Now do it for y input. Mouse input.y equals math f.clamp, and we want to clamp value for mouse input.y minus sway clamp to positive sway clamp. Now let's create a vector 3 for the target position to move the weapon slightly opposite to the mouse movement. Let's say vector 3, target pose equals new vector 3, and for x, minus mouse input dot x, and for y, minus mouse input dot y, and z will be 0. I'm using negative values, so the weapon moves slightly opposite to the mouse movement. Finally, we'll smoothly move the weapon toward this target position. Let's say weapon dot local position equals vector 3 dot lerp, and we'll lerp it from local position of weapon toward target pose plus origin pose, and time dot delta time multiplied by smooth time. We add origin pose, so the weapon always sways around its original position instead of drifting away. Now, let's go back to our weapon controller script. Let's call our weapon sway in our weapon controller script. Private, weapon sway, weapon sway. Next, we need to set the origin pose of weapon sway in the start of our weapon controller script. In start, let's say weapon sway dot origin pose equals transform dot local position. This is important because our sway system needs to know the default position of the weapon. Let's create a dedicated method to apply weapon sway in weapon controller. Inside this method, we'll call the sway function from weapon sway class and pass this transform in it. Let's call this method in update. So every frame the weapon checks mouse input and smoothly applies sway movement. Now check the inspector for weapon sway extra attributes. As you can see, we have weapon sway attributes here. Let's test the sway system. Let's move our mouse. And you can see our very cool weapon movement. Now, our weapon sway system is working nicely. And before we move to weapon recoil, let's quickly improve our hit effect system. Right now, we only have a blood hit effect. So even if we shoot walls, floors, or other objects, we don't have any effect, which obviously does not look correct. So let's add a default impact effect as well. First, let's create another game object variable for the default hit effect prefab. To do this, just duplicate blood hit effect and rename it to default hit effect. Next, we also need to create a tag for enemies. Let's add public string enemy tag. Now we can easily identify whether the ray hit an enemy or a normal object. Now inside raycast hit check, we are going to add the tag condition. We'll simply check if ray hit dot collider dot tag equals enemy tag. Then we'll apply damage, blood effect, and impact force. We'll move our damageable system inside this check. Now, if the object is not an enemy, we'll go into the else condition. Here, instead of blood, we'll spawn a default impact effect. Rename blood to default effect. An object to instantiate will be default hit effect. Position and rotation remains the same. Now, let's destroy this default hit effect after 2 seconds. Now let's initialize the enemy tag and name this tag as enemy with capital E, copy the string. And add a new tag with the same string. And assign the tag to enemy. I have already imported default metal impact in my project. And I'm going to assign its reference. Now let's test the game. Let's start shooting. As you can see, when I hit the walls or ground, we have a metal hit effect, and when we hit enemy, we have blood effect. Now, one thing to keep in mind is hit effect logics are just for the time being. Right now, we're simply checking enemy tags and manually spawning different effects. But in future episodes, we'll make this system much more generic and scalable. We'll create a proper surface hit system using lists. So different materials like metal, wood, concrete, flesh, and glass can all have their own unique hit effects. Now let's move to the final feature of this video, and that is adding a weapon recoil system. Right now, our weapon sway is already making the gun feel more dynamic, by handling the weapon position movement. But when we shoot, the weapon still feels a little stiff because there's no firing kickback. So now in this recoil system, we'll handle the weapon rotation. This means every time we shoot, the weapon will slightly rotate backward and then smoothly recover to its original rotation. And this instantly makes shooting feel much more satisfying. Let's do this. First, create a new script. Let's call this weapon recoil. Open up the weapon recoil script. And just like our weapon sway system, we don't need mono behavior here either, because this is not an independent component. This will simply act as a helper serializable class inside our weapon controller. Let's add the using system and make this class a serializable class. Let's remove our start and update because they are useless now. Now, the very first thing we need is a recoil rotation value for this. Let's add private vector3 recoil rotation, and it's equals to new vector3. And x value will be -5, y will be 2, and z will be 0. I guess instead of serialized field, I added serializable. Let's fix this quickly. Now, let's understand why we need this. This vector3 controls how much rotational recoil we want on each axis when firing. The x value controls vertical kickback, so -x will make it to rotate backward, and the y value controls left and right randomness. Next, we need recoil speed, private float recoil speed, and set its value to 10. This controls how quickly the weapon rotates toward the recoil direction. Next, we need recover speed, private float recover speed, and set its value to 8. This controls how quickly the weapon comes back to its original rotation after firing. Now, we need a variable to store the current recoil rotation, because recoil is not just a one-frame rotation. We need a value that smoothly changes over time. Let's add private vector3 current recoil rotation. Next, we need to store the weapon's original rotation, so the recoil system will always return the weapon back toward this original rotation. Let's add public quaternion original rotation. We hide it in the inspector and make it public because we'll automatically assign it from the weapon controller script. Next, we need a function that will continuously update recoil every frame. Let's say public void handle recoil and pass transform parameter for weapon so we can rotate it. First thing in this method to do is we'll smoothly recover recoil back to 0. Let's say our current recoil rotation equals vector3.lerp, and we want to lerp it from current recoil rotation to vector3.0, and time.delta time multiply with recover speed. Now, finally, we'll apply rotation to the weapon. Let's say weapon.local rotation equals quaternion.slurp, and it is from weapon.local rotation. Toward original rotation, multiply with current recoil rotation, and convert vector3 recoil values into rotation. And for smoothness, time.delta time multiply with recoil speed. Next, we need a function that will be called every time the player shoots to add recoil rotation. Let's set public void apply recoil. Inside this function, we'll add current recoil rotation plus equals new vector3, and for x value, it's recoil rotation.x. And but for y rotation, we'll use random.range. So this creates slight left and right randomness every shot. And the range will be from minus recoil rotation.y to plus recoil rotation.y, and z will be recoil rotation.z. Now, let's go back to our weapon controller script. First, add a weapon recoil variable, private weapon recoil, weapon recoil. Now inside start, assign the original rotation of weapon recoil. Let's say weapon recoil dot original rotation equals transform.local rotation. This stores the default weapon rotation for recoil recovery. Next, we'll create a dedicated method to handle weapon rotation in every frame. Private void, apply weapon recoil, and inside this method, call our weapon recoils handle recoil method, and pass this transform for this weapon recoil. Call this method in update, so every frame, the recoil system updates the weapon rotation smoothly. And finally, whenever we shoot, we simply apply recoil from weapon recoil class. So now every bullet adds recoil kickback to the weapon. Back to editor. As you can see, we have extra attributes for weapon recoil in our weapon controller system. Let's test the game and start shooting. You can see our weapon now has a nice kickback effect. Every time we fire, the gun slightly rotates backward and then smoothly recovers to its original position. And honestly, this already makes the weapon feel much more realistic and satisfying compared to a completely static gun. In the next episode, we'll make the weapon movement feel even more polished by adding idle sway and movement-based weapon sway.